Practice finding the critical values for this equation on your own first, and then continue watching to see how we did it. So the critical values occur where the derivative equals 0 or the derivative does not exist. So I found the derivative first, and based off of that, I can see that this part right here would give me a fraction with x in the denominator. And so that already tells me that I'm going to have a critical number at x equals 0. But that's the only one where I can see where it does not exist. So now I need to look and see, where does the derivative equal 0? So I set my derivative equal to 0, and I solve from there. In order to do that, I'm going to go ahead and move the terms on separate sides. And while I could actually solve it just from this form, you might find it easier if you simplify those fractional and negative exponents first, because this puts it in a nice format to be able to just cross multiply from there. Now when I do that cross multiplying, this multiplication is the critical one. Of course, the negative 5 times 3, that's not necessarily the trickiest part there, but the cube root of x squared times the cube root of x, that is the part we need to be able to handle. Cube root of x squared, that's just x to the 2/3. And the cube root of x, that's just x to the 1/3. And I'm multiplying them. So that means I'm going to be doing 2/3 plus 1/3, which is just 1. So that one conveniently just works out to be x to the power of 1. And so then that equals 30. So if I divide them both sides by the negative 15, I find that x equals negative 2 to get my other critical number there. And so these are my two critical numbers at x equals 0 and negative 2. Now keep that work handy, because this was really just kind of lay the foundation for where we're headed today, which is looking at the absolute extrema of a function. Now, the absolute extrema happen over a particular interval in this case, so you can see that we're looking at the same equation, except on the interval from negative 5 to 1. And we're going to be looking to see, where does this graph hit its highest point and its lowest point in that time. Now, again, to kind of give you a visual to tie this onto, this is what we're going to be looking at here. This is the graph of this function in that time. So you notice that it's going up in that, and then it comes back down, and then it goes back up. So we want to figure out, where does it actually hit its highest and lowest points throughout that entire journey. And you can see our candidate points here would be here, 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 and up here someplace. Well, notice what's really meaning that we got to look at then. So 2 of those are the endpoints. So I need to check that endpoint, and I need to check that endpoint, because those could be the absolute max or the absolute min for that interval. They might be, they might not be. We have to check to find out. But the other points are here and here. Notice the derivative at this point is going to be 0, and the derivative at the other point there at the bottom does not exist. Those are our 2 critical points. And so in order to find the absolute extrema, we are going to have to test some points. We're going to have to test the endpoints, and we're going to have to test the critical points. This would probably be good to write down your notes then. This is a description about the process that we will use going forward through this lesson on how to find the absolute extrema over a particular interval. So going back to our problem that we were starting with, we know our endpoints. We also know our critical numbers. And so what we need to do now is figure out for each of those x values, because the endpoints are just the x values, and our critical numbers are again just our x values. For each of those x values, what's the corresponding y value? Or in other words, what's f of each of those values? So I'm going to take each of those numbers and plug them into this original equation to see what that's going to give me. And so I plugged each of those x values into the equation, and I ended up with these y values. So now in order to find my absolute extrema, I'm looking for what are the highest and what are the lowest y values. And so first of all, the highest value looks like it's right there, because that's at 6. So that's going to be my maximum value. Then I look through that list for the lowest values. And it looks like I actually have 2 of them here, because I have 2 of them that are down at 0. So it's a tie. So both of those are actually going to be an absolute minimum for this particular interval. And again, notice I can talk the absolute minimum here being at both of those points because it's specifically over this interval. And so this is how we then finalize that answer. And again, looking at that picture with the numbers now in there to be able to see what was really happening there.